Hey everyone, this is the third video of 3 on limits, and this is where the limits are going to involve infinity, kind of the more algebraic version versus the graphical version that we looked at earlier. So this is going to be problems where when we try to take the limit by sort of the idea of at least plugging in a value, we end up with something that comes out infinity over infinity. So for instance, just looking at this first example, if I put infinity in here for 5, infinity of minus 5 is pretty much infinity still, right? And then infinity squared plus all this other mess, still infinity. So we're getting infinity over infinity, so that's another indeterminate form. It's not giving us the information. And so there's a bit of a more formal way of looking at this that you can totally check out in the book, but I'm going to kind of cut to the chase on it and just explain what the dominant term property is, which is we take the dominant term in both the numerator and denominator, and then reduce and then see what happens. And the reason for that, let me do like a really simple version. Let's say I have 3x plus 1 over 2x plus 5. If x is 1,000,000, this is pretty much 3 million over 2 million, which when you reduce is going to be 3 halves. And this plus 1 plus 5 stuff, when x is 1,000,000 plus 1 is pretty much still 1,000,000. And so as we let, for larger and larger values of x, this is going to approach the ratio of those leading terms there. So that's kind of the idea of how we're looking at this. And so in this case, they were the same, so I was able to just sort of reduce the terms. With this, I'm going to do the same idea where we're looking at these leading terms, but we're going to have kind of 3 different cases, and this is actually going to end up being the middle one here. So let me show you what happens. In this first case, notice the power on the numerators, it's like an x first in this case, and the denominator is an x squared, but this is kind of a smaller power over a larger power. So if I do the dominant terms, I'm going to have x over x squared. I'm doing the limit as x goes to infinity of that. And that's the same thing as the limit as x goes to infinity of, so I could cancel out an x, and that gets me 1 over x. So as x goes to infinity, 1 divided by 1,000,000, that's going to get really close to 0, right? So then the limit is for this is going to be 0. And that's going to be the case every time you have one with the denominator smaller than the numerator. And that's because when we do that division, it reduces and we get kind of a 1 over situation. So for this next one, these are our dominant terms. And so if I do the limit as x goes to infinity of 5x squared over 2x squared. So again, here the x squareds cancel. So the limit as x goes to infinity of 5 halves is just 5 halves. So when they're the same, it's going to just turn out to be the ratio of those coefficients like I did up here. And then this last one, so if I try this, I'll end up with the limit as x goes to infinity of x squared over x. So notice this was small over big, same. Now we're big over small. When I reduce this one, I get the limit as x goes to infinity of x, and that would be infinite, right? So that is a DNE. And that is how those work.